Alright, today we are going to be doing 5.6, the law of cosines. So the other day we did law of sines, and remember that dealt with triangles of the angle-angle side case or angle-side angle, and that gave one triangle. And then we had the other case where we had side-side angle, and in that case we could have 0, 1, or 2 triangles that it formed. But the law of cosines works for the side-angle side case or the side-side case. Those are the two options that it goes with. So as far as the actual law of cosines, and I will say your book does a little bit better job with this than they did with the law of sines, but some of this I'm still basing off of the Algebra 2 book because I think it makes it a little clearer. So, law of cosines. If triangle ABC has sides of length A, B, and C, and these are all lowercase, then, and let me draw a triangle over here for us so we have it for a reference. We have A, B, and C, and then its side lengths obviously are opposite of the angles. So A, B, C. Alright, so if that's the case, there's three possibilities for how this looks. A squared is equal to B squared plus C squared minus 2BC cosine of A. So this kind of almost looks like the Pythagorean theorem here a little bit, but then we tack on this minus 2BC cosine A. So whatever the side length that we're quote-unquote solving for here, that angle is the one that goes here, and then we have B squared, C squared, and then we have B and C. So these letters get repeated here. And this is just kind of the pattern to help you follow. So that being said, then we could solve for B squared is equal to A squared plus C squared minus 2AB cosine of, or sorry, 2AC, there we go, cosine of B. And then lastly, C squared is equal to A squared plus B squared minus 2AB cosine C. Okay, and because this works for the side angle side case, okay, as well as the side case, you have to recognize that sometimes you might actually be solving for the angle because you're solving for a triangle. If you're given all the side lengths, then the only thing you have to do is find the angles, meaning you're going to have to use one of these, and then most of the time, I would say, you switch to law of sines after that. Now, you don't have to, but that's probably the most common thing that happens here. You go use law of cosines in the first step, and then you go law of sines, and then you can just do 180 minus those two angles to get your third angle. So, let's go through and look at a few examples here, and then we'll go and we'll look at some area problems and all of that, because there's some area for both types that we really haven't looked at yet. So, see. Alright, so 5 through 16 is solving the triangle, and then it says that in some cases there may not be a triangle that's given by the given side lengths, which requires you to think back to geometry and the rules that you had there for if you even have a triangle. and knowing the rule about the sides and what that means. Basically, it's that any two sides added together has to be greater than or equal to the third side. So I'll show an example of how we know one of them is not a triangle here in just a minute. But first, let's do one that is. I'll start with something kind of easy. Start with 6. B is equal to 35 degrees, A is equal to 43, and C is equal to 19. Alright, so in this case, we're given the angle, and we're given two sides, so we want to find the other one. So since we're given angle B, we're going to be solving for this B squared value here. I mean, if you don't have your calculator, you are going to need that here in just a second, so make sure you have that handy. But set up the problem. Just to get in the habit, I recommend you write the formula down every time, just so that you get familiar with the formulas and stuff, but I mean, you don't technically have to do that. And I, a lot of times, like to go ahead and just get rid of this square root, like solve for B. So B is equal to the square root of A squared plus C squared minus 2AC cosine of B. So that way I just already have it taken care of, so now I can just punch everything in nice and easy. So this is equal to the square root of 43 squared plus 19 squared minus 2 times 43 times 19 times the cosine of 35. So, again, make sure your calculator is in degree mode so there's no issues. And we're just going to type all this stuff in. Make sure you're using parentheses and stuff properly so that you don't end up with any issues. Let's see. So if you do that amount of parentheses and stuff, you should be good the way I just did it. So I did each individual one in parentheses, and then I did this whole chunk here in parentheses. And it should come out fine after that, because it'll do everything in parentheses first. So the square root of that is 29.5. We'll just call it 30. Okay, we'll round up to the nearest whole number, so B is equal to 30. And because we are solving for the triangle, we do still want to set it up the same way with our A, B, C values for each so that we can write down everything. It just makes it easier for me to grade. So B is 35 degrees, A is 43, B is 30, C is 19. So now we need to solve for another angle. It doesn't matter which one we do next, but I'm going to use the law of sines now. So this is the law of cosines. So now we're going to jump down and use the law of sines. So let's just say I want to solve for A. So I'm going to do the sine of A over 43 is equal to, well, I have both B values, so sine of 35 over 30, multiply by 43 and take the arc sine of that. So A is equal to the arc sine of 43 times the sine of 35 all over 30. And you can do that on your calculator. And I get that that is 55.2, so we'll just call it 55 degrees. So then for C, it's going to be 180 minus 55 minus 35. Which comes out to be 90 degrees. And let me check this answer really quick because it doesn't seem right. The biggest angle has the smallest side. Something seems off here. So I need to check. Let's see. This is 5.6. And obviously our answers might be a little bit off, but that seems pretty off to me, so it tells me something is probably wrong. Let's see, 6. So yeah, they get A to be 123 and C to be about 22. So I'm going to check something here and we'll see, because I think what I remember finding when we did this in Algebra 2 was that sometimes it made a difference which one of these angles you chose to go with. Sine of 35 over 30. So C is equal to the arc sine of 19 sine of 35 over 30. Okay, so it does make a difference. Okay, because this gives you 21 degrees if you do it this way, meaning then that A is 180 minus minus 21 minus 35, which is 124 degrees. So it does make a difference which one you use. Okay, in this case, we would have A is 124 and C is 21. So I think the rule that I came up with for Algebra 2, and it's my fault that I had forgotten about it, okay, but I did want to show you what happens. Let me rephrase. It's good that I made this mistake here, because this is something, I wouldn't really say it's a mistake, but it is important to see what happens here, okay? I think the rule that I made for them is whenever you switch to the law of sines, go with the one with the smallest side that's left. So, when switching to the law of sines, choose the angle with the smallest side length. Okay, so that's the rule I will make. However, if you do not do this because you forget, don't think about it, I will be accepting of both. Now I want you to see why I knew there was a mistake here, or why there's an issue here. When we look at triangles, our smallest angle should be with our smallest side. Well, 35 and 30, 55 and 43, those two are good, but then I came down here to this 90-degree one, and my side length was 19, so I knew something was off. So what I want you to do is I want you to use this. When you switch to the law of sines, choose the angle with the smallest side length. So, meaning, after I got this, the information that I had after completing the law of cosines here, I had A, C, I just found B, and I had angle B. So, based on what was left, what you should have done was you should look over here and say, well, this is the smallest side length, so this is the angle I want to find first. Okay, and that should resolve any issues. That should give you the answers that the book has. Okay, that's what we found to be true. Now, like I said, if you did it the way that I did it here, okay, because you don't think about it, whatever, I will accept this answer. Okay, but a comment you should make here is that something about this doesn't make sense. Biggest angle has smallest side. Okay, if you make a comment like that and let me know that, you realize, hey, I made a mistake, or whatever, make a comment like this, and I'll know that, hey, you recognized that this is not good, but you had already solved it, and I don't want you to have to go back and like resolve it with something like that. Okay, so always go with the smallest side when you're doing the law of sines. So we're going to do another one so that I can fix what I just said and do it correctly for you. So, I need to get my marker back. Okay, let's do another one. 10. We're told that A is equal to 1, B is equal to 5, and C is equal to 8. So the first thing I need to do with this one, okay, with the sides, is I need to verify that this even makes a triangle. So verify that it is a triangle. Okay, and remember, for it to be a triangle, when you add up two sides, it must be greater than the third side. Okay, so with this one, earlier I said greater than or equal to. It is just greater than. So A plus B needs to be greater than C. So 1 plus 5 greater than 8. 6 greater than 8, not true. Therefore, it is not a triangle. Okay, no triangle is formed there. So that's all you'd have to do for ones like that. And the ones you'll have for homework, you will have two that are not possible. Okay, so let's go back and do another one. 14 looks good. Let's do 14. 14a is equal to 57 degrees. Little a is equal to 11. And b is equal to 10. Now, with this one, we could go back and we could look at our old methods to do this. Because we're given an angle, its matching side, and another side, but we also can try it with this method, I believe. So we're going to go for it and try it and just see what happens. So in this case here, Okay, I'm doing the law of cosines. So ultimately I need C, but I don't know what the angle of C is. So because I know angle A, I'm going to go with the first option. I'm going with A squared is equal to B squared plus C squared minus 2BC cosine of A. Just debating if this is the best option with this one. Okay, honestly, because of having to move this C squared over and then also getting rid of this C that's being multiplied in here, while we could do this, this is probably going to take way more work than you guys want to do. So at this point, we would switch over and just go law of sines. We'd get rid of that method. We'd go law of sines, which you guys should know. So let me find a different one here that I can do that's not like that. Alright, we'll just go with 8 so that way you guys can actually see a law of cosines one. You guys should be able to do law of sines on that one based on the previous lesson. So, back to 8. B is equal to 22, C is equal to 31, A is equal to 82 degrees. Okay, so here, okay, what you need to do is we need to set up law of cosines. Because I have this angle A and I don't have side A, I'm going to solve for side A. So I'm still using this formula that I had just written up here. A squared is equal to B squared plus C squared minus 2 BC cosine of A. So then A is equal to, I'm just going to go ahead and do the square root and then just start filling in numbers. 22 squared plus 31 squared minus 2 times 22 times 31 times the cosine of 82. And then on your calculator, you can just type it in. Just doing it off to the side. You guys can do it at the same time if you want. So 22 squared. And I would do this stuff in parentheses so that it doesn't get mixed up in its order of operations, because our calculators are not quite as smart as we think they are. So make sure you pay attention to that. And I get 35.4, so we're just going to call it 35. So now I'm going to set up over here A, B, C. Alright, so now I can fill this in. 82 degrees, 35, B is 22, C is 31. Now, looking at this one is my smallest side, so I'm going to do the law of sines on B. So, sine of B over 22 is equal to sine of 82 over 35. Multiply by 22, take the inverse of this, so B is equal to the arc sine of that 22 times the sine of 82 over 35. And you can do that on your calculator. 22 sine of 82 divided by 35. And then take the arc sine of that. And that gives me that B is 38, because I got 38.49, so that would give me 38. Now, 180 minus 82 minus 38 gives me 60. So 60 degrees. I can verify biggest side, biggest angle, medium, and smallest. So this right here is the official right answer, done in the correct format, correct order, and everything for this. Now, and I'm going to take off the ones that would require you to use law of signs from this homework because you've already done law of signs. Another thing, if you don't understand it, please make sure you let me know and ask questions. But I will take those problems off from this set of homework. But now we need to look at area of triangles when we're not just given a base and a height. Need to see what that looks like. So when we're doing area, we have a couple options. We have two different formulas. The first set is primarily used after using the law of signs or with problems that you had enough information to use the law of signs. Not that that has to be the case, because sometimes what happens is they will give you not enough information and require you to find one of the other pieces. But the second option you can only use when you're given sides. But if you're given an angle, you can use this method here. So area of a triangle. Alright, so area is equal to 1/2 BC sine A, or it's equal to 1/2 AC sine B, or 1/2 AB sine C. Okay, so those are your three options. Okay, and like I said, sometimes you may have to actually solve the triangle first in order to get it to come up. Let me try to get this back in focus. I don't know if that helped. Put a worksheet under here. It likes things that are printed better than my handwriting to focus it, so there we go. Alright, so now what we're going to do is I'm going to go ahead and, we're going to go ahead and do an example that uses this, and then we'll go down and use the other option here in just a second. And it's nice, it appears your book is nice enough to always give you all the pieces, meaning you don't have to like solve the triangle to do that. That's something that the Algebra 2 book does not do very well. So, and I'm probably just going to do one of these because it's just plugging it in the formula. But if you guys are struggling with it or something, just let me know, and I don't mind doing some more. So A is equal to 52 degrees, B is 14 meters, and pay attention to the fact that these have units. C is 21 meters. So I just got to find the formula that has all that stuff involved, and that's going to be this first one. So A, now obviously that A is area, that A is my angle. So A is equal to 1/2 BC, so 14 times 21. And remember, like I said, keep up with the fact that your units here are in meters. Sine of 52 degrees. And then you can just do that on your calculator. And I get then the area, and we'll still round to the whole number. So I got 115.837 blah blah blah. So we'll round that up to the area is equal to 116 meters squared. Still is the proper way to write this. Okay, your book rounds to decimal places, but I'm fine with you just rounding to the nearest whole number for this for now. Just keeping it easy. Okay, so these ones, they just give you these pieces of information, and you just simply plug them into these options up here at the top. Now, the next thing we have, it's called Heron's area formula, and you should have seen it before, hopefully. But Heron's area formula. Okay, so the area of the triangle with sides of lengths A, B, and C is area is equal to the square root of S times S minus A times S minus B times S minus C. Ooh, sorry, that's really crooked. Where S is equal to 1/2 A plus B plus C. This variable S is called the semiperimeter or half perimeter of the triangle. So, whenever you're solving area using this method, okay, this is when it gives you all three side lengths, no angles. What you need to do is you need to find S first. So you're going to take 1/2 of A plus B plus C, and that's going to give you S. And then you just take it and you plug S in, and then the other A, B, and C just as it goes in the formula there. So now, what happens with this set of problems here is that it says to decide whether a triangle can be formed with the given side lengths. If so, use Heron's formula to find the area of the triangle. So 21 through 28, there are a couple that say no triangle is formed, and it's for the same reason as what we looked at before. So we'll do a couple problems here to make sure you can see this formula used and everything, since it's not just simply plugging in. It involves an extra step. So let's just start out with 22. And so that one is A is equal to 5, B is equal to 9, and C is equal to 7. So the first thing we need to check and verify that it is a triangle. So 5 plus 9 is equal to 14, which is greater than 7. So that's good. Let's do 5 plus 7 is equal to 12, which is greater than 9. So that's good. And lastly, 9 plus 7. This one is obvious, but 9 plus 7 is equal to 16, which is greater than 5. So that's good. So now we can proceed using Heron's formula. So we need to first find S. And S is equal to 1/2 A plus B plus C, which is 1/2 A is 5, plus B is 9, plus C is 7. So 9 and 7 is 16, 5 is 21, divided by 2. So we'll leave that as 21 over 2 for right now. You can convert it to a decimal if you want. And then we're going to go over here. Now we need to actually set up the formula. So A is equal to the square root of, and just so we have the formula, S times S minus A times S minus B times S minus C. So now plugging in stuff, this is equal to the square root of, and I'm going to go ahead and rewrite this as 10.5, just for the ease of writing it in. So 10.5 times 10.5 minus A is 5, times 10.5 minus B is 9, times 10.5 minus C, which is 7. And so now I can go through and just type that in my calculator. And make sure you use your parentheses and stuff, like I said before. So take a minute and do that. Make sure you pay attention to your decimals, because I just did one and did not have the decimal in between here, and so my answer was way off. Alright, so I get 17.41 when I do that, so we'll just say area is 17. They do not give us units, so I'm not worried about it here, so that's just going to be 17. Let's see, 26. Says A is 8.2, B is 12.5, and C is 28. So we first want to check and verify that it's a triangle. So 8.2 plus 12.5 is equal to, that looks like 20.7, which is not greater than 28. Therefore, no triangle is formed. Alright, so let's do one last example so you actually get another one that uses the formula. 28. 28, A is 18.2, B is 17.1, and C is 12.3. Alright, so I'm just going to kind of check them over here. 18.2 plus 17.1. And I know that's obviously going to be greater than 12.3 because both numbers are greater than. This one, obviously I can see 17.1 and 12.3 is greater than that. And ultimately I can see that those two are greater than that. So I don't even really need to check it. I can just verify there that I've checked it. And if you just do that and just show me that, give me a little check, show me that you did check it, I'm good with that. Alright, so S is equal to 1/2 A plus B plus C, so 18.2, plus 17.1 plus 12.3, and decimals, so I'm doing my calculator. So this comes out to be 23.8, so that's the number I'll be using. So now area is equal to the square root of S, which is 23.8, times 23.8 minus A is 18.2, times 23.8 minus 17.1, times 23.8 minus 12.3. So it comes out to be, you do it in your calculator, so I get that A is 101.337 and so on, so rounding area is equal to 101, and that's all there because there's no units. Alright, so your homework, which is going to be due Monday at midnight rather than Sunday. Okay, I had some technical issues. Yesterday when I tried to come over and record this, I recorded a video for another class like 3 times, and it still never recorded. I had a lot of issues. So, that's why I'm bumping this one a day, since you don't really have a full school day to do it at this point. So your homework is going to be five through 11 odd, and then 17 through 27 odd. Okay, these ones are just area problems, and they should be pretty easy. Okay, and I did take out the law of signs problems that were in there, so anyways, there will be probably a quiz on 5.5. Well, maybe writing some of the formulas from 5.4, but 5.5 and 5.6 next week sometime, posted for about 24 hours on Google Classroom that you'll be responsible for. So if you have questions as you're doing this homework this weekend, Monday when it's due, okay, make sure you let me know so that I can get something out there for you guys to help with anything that you guys are having issues with, or just put a question mark by the number or circle your number or something so I know that I need to go over those problems for you. But yeah, have a great day and enjoy your weekend.